All right, so looking at Malthusian models here, you can read through this question yourself, but I'm just highlighting some important information before we get started. All right, so we're going to write this differential equation. So what we're going to say is that the change in population with respect to time is equal to 2% per year, 0.02 of the population, 0.02 times the population. From here, we're going to rearrange that differential equation. We're going to move the dt to the top on the right-hand side, or multiply by dt on both sides. Let's do it. And then that p we're going to divide by, but really not divide by, multiply 1 over, which is the same thing, 1 over p. And take the integral of both sides. All right. You're going to learn more about differential equations a bit later on, but this is what we're doing. Now we're going to integrate both sides of this. Now the right-hand side, that's pretty easy to differentiate, 0.02t and a c plus c. And this other one is the natural log of p plus c. Now because we've got a plus c on both sides, we can just sort of merge them into 1 plus c because we're just adding a constant. All right, we can rearrange this into exponential form. So that's going to be equal to p equals e to the power of 0.02t plus c, and we can just split that up. P equals e to the 0.02t times e to the c. All right, so we're going to find c using some known point, and we know that in 1961 the Earth's population was 3,060 times 10 to the 6. So I'll just let 1961 be time equals 0 and sub in those values. Now, by subbing in 0, e to the whatever is going to be 1. And now we know that e to the c is equal to 3,060 times 10 to the 6. Now, I said we were going to find c, but we don't really need to find c. E to the c is good enough because e to the c is just a number. Now we can just write that finished equation. P equals, now I'm just going to change the e to the c and the 0.02 around. So I'm going to put e to the c at the front, which is 3,060 times 10 to the 6, and multiply by e to the 0.02t. And now I can, the first question here is to find the Earth's population in the year 2010. So that's going to be t equals 49, given 1961 was equal to 0. Sub in 49 and we'll get an answer. It's really straightforward. Let's just put that into our calculator. All right, so the second question here is if the total surface area of our planet is this, how many square meters will be available? So it's just an extra little problem here. Area per person equals a total area over the number of people. So you need to just be a bit careful here with the billions of square meters and all the rest of it. So we're just going to have to turn that into 1.67 times 10 to the 5 times 10 to the 9, which is a billion. And we just sort of work through this. We should be able to just type it into our calculator here, or we can do some cancelling, and you'll get an answer of 20,483 meters squared.